Okay, just a quick warning. There's people doing work at my house right now, and the dog is in the room with me. He may bark suddenly, just so you know. Okay, so in this problem, so you're asked to graph y equals cotangent of 5x. So the place to start is to have to be aware of the shape of just the basic function here, which would be just cotangent of x. So the cotangent graph, well, one way that can help justify what the graph looks like is to write cotangent using one of those ratio identities. Cotangent is equal to cosine x over sine x. So the graph of y equals cotangent x has a vertical asymptote. Just generally speaking, functions have vertical asymptotes when the denominator is equal to 0. So in this case, when sine of x is equal to 0. So sine is 0 when x equals 0. So there's going to be a vertical asymptote here at x equals 0. And then again when x equals pi. So there'll be another vertical asymptote here. When x is pi over 2, so right in between here, cosine of pi over 2 is 0. So you'll have 0 over 1, because cosine of pi over 2 is 0 over sine of pi over 2 is 1. So cosine of pi over 2 is 0 over 1, which is 0. The cosine graph has a decreasing shape. So it looks like the graph of y equals tangent x, except it's decreasing instead of increasing, and it's got asymptotes in different places. You may recall the graph of y equals tangent x has vertical asymptotes at negative pi over 2 and pi over 2. So for cotangent, the asymptotes are at 0 and pi, and the graph goes downward. So it repeats this, we call it a branch of the cotangent graph. It repeats that branch over and over infinitely many times. But I'm going to focus on this, just the one cycle from 0 to pi. Now, so this is for cotangent of x. The fact that you have 5x here is going to change the period of the graph. So if the typical period of a cotangent graph is pi, because that would be the length of the interval from 0 to pi. That's the interval that gives us one complete cycle. Then the fact that we have cotangent of 5x, we should divide that period for the standard cycle, or for the standard cotangent graph, by 5. So the period is going to be pi over 5, which means you get one complete cycle for the graph of y equals cotangent of 5x. X goes from 0 to pi over 5. So that's going to be where the new asymptote is. And then there's no negative in front of the cotangent. There's nothing else going on in this function, so it's going to look like that same cotangent curve. Just the only difference is the asymptotes now are at x equals 0 and x equals pi over 5. Another way of getting the location of those asymptotes, so at 0 and pi over 5, is to solve an inequality. So similar to what we did with sine and cosine. So since you have cotangent of 5x, you can find, and I'm sorry, I'm writing all over the screen here, but you can find the x values for one complete cycle by taking that 5x and putting it between 0 and pi. And the reason I'm using 0 and pi is because that's the starting and stopping x values for our standard cycle for cotangent of x down here. So then you would divide all three parts by 5. 0 divided by 5 is 0. So the cycle would start at x equals 0 and end at pi over 5. So this graph looks good. Yeah, and that's the one of these choices. A is the one that has the cycle going from 0 to pi over 5 with the decreasing shape that we know that the cotangent graph has. See, this one here is increasing. This one's decreasing, but it's got that asymptote in the wrong place. Oops.